Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tare, and this is my continuing feature on the Math Lovers book. And I'm up to chapter 3, which I just started yesterday. I'm on section 3.1, which is on fractions and decimals. And yesterday I talked about how to convert an arbitrary fraction or arbitrary rational number, if you like, into a decimal. Today I'm going to go the other way. I'm going to talk about how to go from a decimal to a fraction. This is trickier, but it's not too bad. I'll show you how to do it. So anyway, let's begin. So anyway, I think I'll just jump into an example here. I already explained what I'm doing. Um, but suppose we're given the decimal. I mean, it's easier with terminating decimals. So I'm going to start with a couple terminating decimals because those are easier. So suppose we have the decimal 0.48 and we want to convert that to a reduced fraction. Well, it's pretty straightforward if it's a terminating decimal. We just use a definition of a decimal. 0.48 means 48 over 100 because, the 4 is in the 10th place, the 8 is in the 100th place, so you can just read this decimal as 48 over 100. That's just what it means. But we still have to reduce it. So the next thing we have to do is we have to look for the greatest common divisor, or GCD, of a 48 and 100, and we have to divide by that. Well, it turns out that the GCD of 48 and 100 is 4. You can calculate that. I went over GCD a few weeks ago. You can review that lesson if you need to review how to compute GCDs, but it's pretty straightforward. So that means we have to divide both the numerator and denominator by 4, and when we do that, we get 12 over 25. So that's the answer, 12 over 25. Easy enough. How about a little bit harder one? How about 0.375? How will we convert that to a fraction? Well, same idea, except this time we're dealing with thousandths. So 0.375 is just 375 over 1,000. Well, now these are a lot bigger numbers we're working with. We have to compute the GCD of 375 and 1,000. But if you do that, it's not too bad. You could use the Euclidean algorithm if you like. That's usually the most efficient way to do it. If you do that, you'll find the GCD of 375 and 1,000 is 125, which means we have to divide both the numerator and denominator by 125. Well, 375 over 125 is 3, and 1,000 over 125 is 8, so that gives us 3/8. So that one's not too bad either. Just the math's a little more complicated. So terminating decimals are pretty easy, or at least they're pretty straightforward. Repeating decimals are trickier. The next couple examples I'm going to give, or the next 3 examples, are all going to be repeating decimals. And I'm going to start with an easy one here. It's always easiest if it starts repeating right after the decimal point. Those are the easiest cases, and those ones aren't too bad. So suppose we're given 46.7 repeating. Well, 0.7 repeating. If you have a decimal that starts repeating right after the decimal point, the denominator is always a power of 10 minus 1. And in this case, since the period is 1, it's just 10 minus 1, 10 to the first power minus 1. That means that 7.7 repeating means 7 nines. 0.7 repeating is the same as 7 nines. I don't think it's too hard to see that. Anyway, it's true. But so 46.7 repeating is just 46 and 7 nines. So we didn't have to do too much work to get that. Let's try a harder one. Here's one where the period is 2 rather than 1. Well, it's kind of the same idea. It's just the math's a little harder here. So suppose we're given the repeating decimal 26.27 repeating, where now the repetition is a period 2, 27 keeps repeating. Same idea. 0.27 repeating is this 27 over 99. See, this time our period was 2, so we had to subtract 1 from 10 squared, or 100 if you like. That gives us 99. So we have 26 plus 27 over 99. Again, now we have to do the GCD. We have to simplify this. The GCD of 27 and 99 turns out to be 9. That means we can divide both 27 and 99 by 9. 27 over 9 is 3, and 99 over 9 is 11. So when we simplify this, we get 26 and 3/11. So that one wasn't too much harder. Now I'm going to give you a hard one. So the hardest case is when the decimal doesn't start repeating right away. And here's an example of one that doesn't. So now we're given this kind of ugly repeating decimal, 0.26, now with 185 repeating. Notice it didn't start repeating right at the beginning. It only started repeating, in the third place after the decimal point. So how do we deal with this one? Well, we have to do this in a couple steps this time. See, we would really like the decimal to start repeating right after the decimal point. Well, how can we make that happen? Well, it's not too hard. We just multiply by 100 in this case, because we have to shift everything over two spaces to the left. If we shifted this repeating decimal two places to the left, you'll see it'll start repeating right after the decimal point. So 100x, if we call the thing we're starting with x, then 100x is equal to 26.185 repeating. And now we just do what we were doing before. So we rewrite 185.185 repeating that's 185 over 999 now, because we have a period of 3, which means the denominator is going to be 10 cubed minus 1, or 1,000 minus 1, which is 999. So now we just have to simplify 185 over 999. If you calculate the GCD of 185 and 999, you'll find that's equal to 37. And 185 over 37 is 5, and 999 over 37 is 27. So that means it simplifies to 26 and 5, 27. So I probably should have gone to this slide here. That's 100x. So now we have to divide the whole thing by 100. We're still not done. So now, since 100x is 26 plus 5 over 27, that means that x is equal to 26 over 100 plus 5 over 2700. So now we just have to write this over a common denominator. Common denominator is obviously 2700. And to get the first fraction over 2700, we have to multiply both the numerator and denominator by 27. So we're going to get 26 plus 27 in the numerator of the first fraction. And that's over 2700 plus 5 over 2700. So the whole numerator is going to be 26 times 27 plus 5. Denominator is 2700. If you work out 26 times 27 plus 5, that turns out to be 707. So the answer is 707 over 2700. So that's how you do these. And every case is kind of like this. So you can always do it using this procedure. Sometimes it gets very complicated, but you can always convert any decimal you're given to a fraction using this procedure. Pretty neat, I think. So that's how you can go from decimals to fractions. And that completes my video for today. So thank you for watching. Long live math, and I'll see you guys next time. Bye.